Good afternoon. First of all, I would like to thank the organizers for their invitation. I'm going to dwell upon the practical and technological aspects to the management of oxygen in wine. Of course, time is limited and I will not be able to speak about all aspects, but I will focus on some key points that sum up the investigations that we've carried out in Pêche Rouge, in Nîmes, and in this part of France, Occitanie, which is maybe a former Roman colony to you, but it belongs to southern France to me. We know that oxidoreduction phenomena have an impact on the quality of wines. For red wines, the impact can be positive in terms of color intensification and astringency. We know that it is very important to protect white wine and young rosé wine, and we know that conditioning is a critical phase because after that phase, nothing can be done in order to improve the wine. And regardless of conditioning matters, we have to be sure that gases O2 is not trapped into the container. So we need to control the oxygen content. Let's consider some theoretical aspects. I will not dwell on it too much, but if you want to understand the evolution of gases in wine, two or rather three and four fundamental laws are to be understood. Once they're understood, you can understand the psychology of gases molecules. There is the ideal gases law, and one of the consequences is that if you create vacuum, volume increases. Dalton's law, according to which a gas is characterized by its partial pressure, and the sum of pressure, the total pressure, is the summation of partial pressures. So if pressure of a gas diminishes, the others will tend to compensate. And then there is Henry's law, according to which concentration is in a balanced situation, and the partial pressure of a gas is in line with the amount of gas dissolved in a medium. Then there is Fick's law and diffusion, according to which the oxygen flow is proportionate to the coefficient in terms of volumes multiplied by surface, and therefore transfer ability for one species is a given data, and you cannot actually exceed this saturating concentration. The dissolution rate increases when exchange surface also increases, and when the gap between the measured concentration and the saturating concentration is higher. Paradoxically, the lower content of wine leads to dissolution. Wine is very rich in carbon gas, and it will probably become have a tendency to become less concentrated. Now, let's have a look at basic values. Solubility, oxygen solubility is equal to 9.1 in water, a little bit lower in wine. These are reference values that are a little bit old because they might change. They can change according to sugar content, alcoholic content, and CO2. You can see that mass volume, well, here normally we consider 22.4 liters as a molar volume, but when the temperature increases, molar volume also does. And here we can see some reference values. 1.43 3% is the content in oxygen. Solubility of the oxygen increases when temperature decreases and when pressure increases. Once dissolved in wine, oxygen combines and leads to oxidative reactions, mainly with phenolic compounds, and consumption rate increases when temperature also increases.